our lines. Today we're going to look at the square root family. So yesterday was x squareds. Today they be square roots. And we're going to look at reflections, which are similar to what we had as well in geometry. So, the square root parent function, or base function, lights on, lights off, let's see. Woo, there we go. The square root function, or base function, we'll write parent function out here. The square root parent function is y equals the square root of x. So that is a function we're going to start with, and we're going to move it left and right and up and down. And today we're going to learn how to flip it over as well. Just like in the squared functions and the quadratic functions, to move it left and right, it would go under the square root sign or inside the parentheses, just like it did yesterday. And to move it up and down, it goes outside of the square root sign or outside of the parentheses. So horizontal moves, left and right, inside the parentheses. Vertical moves, outside the parentheses. And hopefully you remember from yesterday, because this already starts with a negative sign, when we put a left digit in, we'd say like -2. That makes this x minus a -2. So left, it's actually going to be x plus. And right is actually going to be x minus. So it's kind of the opposite of what we think intuitively.
It's just like the formula, just like y2 minus y1. You know, it's the formula for finding that part of the slope. It's just the formula.
You just plug it in and you're good.
I know it's not intuitive.
So, we're going to try a couple today, graphing them. So if you would please grab your calculators out. And we will get the notes online eventually here today. We just obviously don't have them on yet, but we will. If we were to graph that particular equation, I want you to look down on your calculator to your x squared button here. And you can see in yellow above the x squared is a square root sign. We'll use that today. There's another way we can do it too, but I like the square root sign because it gives us the parenthesis right there that we have to try to remember anyway. So just graphing the square root of x first. And I want you to hit zoom 6 so everybody has the same window. Your graph would look sort of like that. So you put in the square root of x and then you hit zoom 6 to get your graph. If I add a +5 outside of, outside of my square root sign, I'm going to say the square root of x, and you have to end your parenthesis every time. Like it won't end it for you. So end parenthesis to say that's where my square root ends. And then +5. When we graph that, where do you think it's going to move? Up 5. And check it out. We're so smart. It already did. And you can even count them like 1, 2, 3, 4, 5. And just see how very smart we really are. You could move it to the left or to the right, then by adding a number underneath the radical. So let's go back to our y equals for a minute and clear out that second line. You can leave the first one just to compare it. This time when you hit your second x squared to get your square root, you're going to say x plus 1 and then end the parentheses because that whole thing goes under the square root. And now when we graph it, it should move 1 digit to the left. And you can see that it does. So exactly the same way we did our stuff yesterday. And we could move it to the left and move it up, just like we did some of those doubles yesterday, if you wanted to, and you would see that it would have moved, thank you, Cynthia, over here, and then it would just shoot up 5, and it would start like there and go this way. questions about just moving it left and right, up and down when we have a square root? Anyone? Okay, then the other thing we're going to be able to do with our square roots is reflect them. And I want everybody who's writing notes to make sure that they write this part down, because it's got a whole lot of stars. Check them all out there. 5 of them. That's always important. So new today are going to be reflections. Reflections are going to take our base function, our f of x, whatever that might be. If you put a negative sign right in front of the x, right with the x, that's going to flip our graph across the y-axis.
It was reading this as x minus 5 and trying to.
If you put a negative sign in front of the whole thing outside, that's going to flip our equation across the x-axis. And we're going to look at a couple of those on our graph as well. This note right here, you're going to come back to this chapter probably 5 or 6 times. Because it's hard to remember. Where do I put it if I want to flip it across the x? Where do I put it if I want to flip across the y? And if it's not a multiple choice question where you can just plug it in and see, you're going to need to go back to that note. So if you're not printing them offline, I'd be sure I wrote that part down.
Mm-hmm. And in the video, it's got stars shooting out of it.
Oh my gosh, Miss Blair, you and your video are killing me. So much fun. Not bad.
In geometry, it was the same way. You had to just write those rules down and keep going back to them.
Okay, so how does that work then? I want you to go back to your graph of the square root of x. So everybody go ahead, back to your y equals, and make just one that says the square root of x. And you should start off where you did before. Then I want you to graph in the second line y equals negative the square root of x. So when you graph the first one, you should see your regular equation that starts at the origin and goes up and expands up as you go. If we put the negative sign out front, like we did right here, that's going to correspond right here, where we put the negative sign out front of everything, and that should flip it across the x-axis. So when we go ahead and graph that, and mine's graphed a little faster than yours did, but you have your original equation here on the top, and then you can see here on the bottom that it flipped across the x-axis. And then just to see what the other one looks like, if you said y equals the square root of negative x, and you put the negative inside, so go ahead and try that. And you can even put that on the third line because it starts to look really fun after a while. So you have the square root of, and use your negative, not your minus key, because that will mess it up, negative x. Then you can see that that time it flipped across the y-axis. So instead of being this one, up here, it flipped over and it went over there. What do you think would happen, for fun, and because math is fun for me anyway, if I made it negative on negative x? It's going to flip over which axis?
X and y.
It's going to flip over both of them. So it's going to flip over one and the other. So if you put in both negatives, negative on the outside, square root, negative on the inside, then it will flip over and over again to be down here in the bottom section. Isn't that fun? We could make something to flip up, a parabola up here. That'd be gorgeous, right?
Your Milo flower.
So let's look for 1 second then. Yesterday we had our quadratics, which was the equation y equals x squared. That started here and went up on the other side. What do we think will happen if we change that to y equals negative x squared? it's going to flip, hopefully. So let's try it out. Make sure you hit negative and not minus, so that will mess us all up. X squared. And now, remember before, it was sitting just like this. Now we took that whole thing that started there, and we flipped it over. If we wanted this to look more bug-like, we could scoot this whole thing up. How do we take this equation and scoot it up? What do we do?
You mean flip it again?
No,
Nope.
I want to move it up. Plus 2. If we add something to the end, it's going to move it up. So if you go back to that last equation, and not inside the plus sign, but at the very end, and we added plus 2, we'll have our wings. It's pretty fun. I mean, you gotta be somewhat creative in your life, right? And then it moved up. And if you don't like that, you could move it up further and further. And it's almost angel-like.
You could enter that in art prize, I think, Miss Rumsey.
I might be able to enter that in our prize.
Mm-hmm.
Some interesting things in our prize. Other questions, thoughts, concerns?
How
We're ready to go?
about Mrs. Rumsey with flipping over the y-axis? I know like that one you wouldn't necessarily see with the, I'm talking about the parabola.
Parabolas cannot flip over the y-axis.
Oh, why not, Mrs. Rumsey?
Because then it's not a function.
Okay, well there we go. Just want to verify to them that we wouldn't be.
When they flip over the y-axis, they are no longer functions because they won't pass their vertical line test, right?
Okay.
And because technically a parabola, when it flips over the y-axis, still looks like it did before.
Right.
But if you are thinking about the parabolas that look like this or the shapes that look like that where they open side to side, clearly that is not a function because it touches in more than one place.
Yep.
Bad news. But those are also not called parabolas.
Just
They
wanted
have
them to realize
their
that
own names.
you could flip some things over the y and the x, but not everything over the y and the x.
Or you can, but it looks exactly the same as what you started with.
Right.
Alright, then, we have our assignment from yesterday that some of you need to finish. And we are going to do page 204. This is your assignment today, page 204. 1, 2, 4, 6, 7, 13, 12, 14. I know 12 got out of order on me there. It okay?
Is that okay?
Alright, then.